Good morning. This is Professor David Weiss, continuing our ongoing podcast programming from New Jersey City University's Institute for Dispute Resolution and its affiliated program called Connecting Bridges and Borders. Today's discussion will be on AI, an important conversation that all of us are having around the world, both academically and within the commercial space. I am privileged to have someone who will be speaking on the topic and is well-versed in both international, domestic, as well as NGO level platforms, and has a passion about AI. His name is Arun Shroff, and I want to welcome him to the show today. He actually is also an owner of several platforms, one that is called MEDIndia, and MEDIndia is based in India, and I believe gets about 2 million views a month, and is a substantial entrepreneurship and innovation platform on its own. Arun, welcome to the show. How are you today?
Yeah, hi, good morning, David. Thank you. Thank you for inviting me to your podcast. Real pleasure to be here and to talk to you today. Thank you.
So I'd like to first start out with a little bit of understanding about your background and educating the viewers on how you developed not only your entrepreneurial spirit, but then weaving that into your specific interest within AI. Maybe you can give us a little bit of a storyline.
Sure. Let me see if I can give you like a 1 or 2 minute overview of my background. So again, thank you for this opportunity. Now, so if I want to describe myself right now, I would say I wear multiple hats, but primarily I'm a tech entrepreneur. I've been a serial entrepreneur for the last 25 years or so. I was born and brought up in India. I grew up in India. I went to school there, but I came to the US for graduate education. I did a master's in computer science, and I worked for several years initially, in the conventional roles as a programmer, systems analyst for many companies in the US. But at some point, and I also worked in consulting and management consulting. So in terms of my academic background, I have actually got an electrical engineering degree from IIT Madras. Then I did an MBA in India from IIM Ahmedabad, and then I came into the US and did a master's in computer science. And this was in the 80s, and actually I specialized, my master's thesis was in artificial intelligence, but it was very early days. But I gave up on AI at that time. It was not the right time, and I worked for several years in different programming jobs. But the entrepreneurial bug hit in the late 80s, and my first company was a systems and networking company. We were selling solutions to businesses and Fortune 500 companies in New Jersey, New York area. Grew that company for 5 or 10 years. And then I went into web development, web hosting, web applications development in the late 90s. When the internet was the early days for the internet. After that, my third company was a digital publishing company, which is what MEDIndia is. It's like a health website similar to WebMD. We get, in the last 12 months, we've got 15 million visitors from 200 countries.
Wow.
And approximately 30 million page views. And the idea of the platform is our basic mission and tagline is to empower better health for everyone. Consumers, we allow them to personalize their health information. We give them a lot of tools to allow them to manage their health better. We also have tools for doctors and so on. The primary target audience is India, but we get a lot of traffic from the US as well. Now, I myself, of course, being based in the US, I go back and forth between India and the US quite a bit because of that. But my focus, in the last 2 years, I started seeing how we could use AI in the health domain. And we started by looking at different problems that we solved using AI and machine learning. And one of the areas we started looking at was medical diagnostics. So we developed a product in partnership with a teleophthalmology company in India to create a way to detect diabetic retinopathy, which is a disease caused by diabetes and which leads to vision loss. And that product is now in field trials in India in about 300 clinics. As a result of that, I also got involved with the WHO and the UN. UN has a program called the AI for Good Summit, which they've had since 2017. where they bring stakeholders from all around the world on how they could use AI in different domains to solve different types of challenges. So I got involved. I was invited to speak at one of these conferences. And an outcome of that was something called the Focus Group on AI for Health, which is an initiative of the WHO and the UN, which again brings people from around the world. It's very new. It's just 2 years old. I'm on the panel of that focus group. I'm one of the editors and topic drivers for one of the topics within that group. So those are the quick 1 minute overview of all the stuff I've been involved with.
Well, I mean, that is an absolutely fascinating story because you cross so many mediums that I think will be very interesting for many of our viewers, both the cross-border serial entrepreneurial medium, building platforms, being involved in international organizations like the WHO and the UN in order to help assist on more global level, how to incorporate the theme that seems to be a very common interest, which is this idea of AI.
Yeah.
So let's just jump right into AI. Can we talk, there's a lot of concern about exactly what AI is. So let's start from the basis of just what is AI?
So, AI is not a new technology, even though we're hearing about it now. It's been around since the 1950s, from the early days of computing, right? So 1956 was the actual year when the term AI itself was coined, and AI, of course, is artificial intelligence. The visionary computer scientist who coined that term was John McCarthy at a computer conference in Dartmouth. And the idea was computing was very low, very in its early days in the 50s. We didn't even have these advanced systems that we have today. But the vision at that time was grand that, hey, this new computing power potentially could be used to create intelligence which mimics human beings. So artificial intelligence was a term invented with this grand vision that computers one day would be able to do all the things that we do as humans, things that require intelligence like, vision and speech recognition, understanding language and logic and all of those things. But again, that was an ambitious goal, and I think they kind of underestimated the effort that would be required, to put it mildly, to achieve human levels intelligence with computers. And they quickly ran into stumbling blocks. So, it took a while. It had its fits and starts. It had its ups and downs. And so they gave up on that ambitious vision, and it became a specialized. Various areas of specialization emerged in AI, and one of those was called machine learning, which was this technique of allowing computers to learn from examples without being explicitly programmed. So that was the first breakthrough that they had in creating human-level kind of intelligence. So machine learning is a subfield of AI which allows computers to learn, where you teach it as though you would teach a child by giving it various examples, and it would learn from the examples, right? And it gets better as it gets more and more examples and more data. But that worked quite well for a while, and then in the late 90s, this whole technique of machine learning morphed into something called deep learning. Neural networks, which is a kind of a subset of machine learning, a technique which uses neural networks which mimic the way our brains are work with neurons. The artificial neural networks are networks of neurons, which allow which have these algorithms which allow it to learn at a faster rate. The convergence of three things is what is causing the current revolution of AI and machine learning. The re-emergence of AI has happened in the last 10 or 15 years because of deep learning. And the reason for that is there are three things which have caused that revolution to happen. One is that these machine learning algorithms need a lot of data. And in the last 10 or 15 years, with the digitization and the internet, we have access to a lot of data, which is not available, let's say, 25 years ago. The second thing is the increase in computational power. A lot of the algorithms of AI and machine learning require a lot of computational power. And that, again, has increased exponentially because of Moore's law. So that has allowed some of these algorithms to run and actually do something useful. And the third thing, of course, is the better frameworks and algorithms which have been developed by companies like Google and Microsoft and Facebook, which implement these algorithms. So these three things converge, and as a result of that, in the last, I would say there was an inflection point probably in 2010 or 11 when this whole technique of deep learning took off and started working actually. That's the reason why, and as a result of that, now we're able to do things that were very difficult to do 25 years ago. Things like speech recognition was a very difficult thing to do using the kind of computing power and algorithms that we had in the 90s. That's possible today. Vision, which is another task which is very difficult to do with traditional programming, is something that can be done very effectively with deep learning. And all of these other things which are possible today as a result of that.
You know, it's very fascinating because when we look at sort of some of the things that were the backstory to how AI has become a public understanding to a limited degree, there are three areas that are really fascinating, and that being the data conversation, and that, you know, data really is an important integral part of how AI is able to function.
Right.
The other is the algorithms and the maturity, we'll say, of the development of the algorithms through the sophisticated sort of technology that we're able to apply to that in order to make them faster and more adaptable. Right. And the third is just recognizing through deep learning the different sectors, which it sounds like can be almost anything that can apply AI in order to increase its process efficiency or to expand its ability to assist in the general consumer or public health or environmental space, and I'm sure the list goes on. My question for you is, there's a lot of controversy over AI. Some are myth, and some is just misunderstood.
Yeah.
And then, you know, how do you approach those questions when you're asked?
Well, a great question. Of course, this is the thing on top of the mind of everybody, right? Because one of the reasons for that, of course, is we could blame Hollywood. You know, Hollywood has had this fascination for robots taking over humanity, right, for a long time. So, you know, with the early Terminator movies, so we have this vision of killer robots, right? And so that has created a little bit of a hype around what is possible with advanced technologies, including, you know, AI and robotics and so on. But that's a misunderstanding of how this technology actually works and what its real capabilities are. I don't think we're right now, even though a lot of people are talking about the danger of AI taking over humanity, because, you know, you can create a supercomputer that's smarter than anything else that we've ever created before, and the supercomputer or the advanced AI would then figure out that the best thing to do is to kill all of humanity and take over, right? Okay, that's the best thing for us. But that's not really going to happen, because what we have today is what we would call narrow intelligence. So all of these, think of a calculator, it can only do math. So AI is similar to that. AI today, in the current state of the art, AI can only do tasks that it's trained to do. So if you train an AI algorithm to recognize pictures of cats versus dogs, it's not going to be able to recognize anything else. It doesn't have what you would call common sense. It doesn't have an ability to have general intelligence, which is what we have. And therefore, I don't think we're in any imminent danger of being taken over by these AI algorithms, right? There are other dangers of AI which are related to things like bias and discrimination, because what AI learns from examples. So if you feed it data that has inbuilt bias, it's going to learn the biased, it's going to have bias in its results and in its predictions. For example, I mean, a good example is the Microsoft, you know, about 5 years back, it trained a chatbot on how to have conversations on Twitter. And very quickly they had to take it down because this bot learned a lot of stuff which was racist. And it was learning from the stuff it was interacting with. So it learned all the wrong things. So that's what I was talking about earlier. It doesn't have common sense. It just teaches whatever you feed it.
So it's almost like a Pavlov's theory of how you train a dog, right?
Exactly.
So let's stay on that topic for a minute, because it sort of opens up several questions that I'd like to explore. So when you're feeding AI, you know, the data itself the controller who controls that data can manipulate or use that data in a way that can create then the biases that ultimately AI can pick up. Is that something that could be a concern?
Yeah, I mean that is the problem. The biggest problem today with AI is that the fact that these things effectively are black boxes. In traditional programming, you have to program it with if then else rules. You say if this happens, do that. With AI and modern AI and deep learning, the way it works is you have this standard algorithm which is fed different types of data, and it creates the model based on the data that it's fed, right? And therefore, if the data has inbuilt bias, let's say, a good example would be, for example, IBM. IBM had trained, I think, an algorithm for recognizing faces, but it was very bad at recognizing. It was trained on data which was, I think, it only used people from North America. So there was a large representation of populations which were not represented. So they took that algorithm, and when they went to Africa, it did a very poor job of recognizing faces of African people with African color.
Right. I understand. So the cultural biases of how the controller populates the data within the AI black box, if you will, is an extremely important part of the process of the functionality of how AI will ultimately work.
Right, because the actual algorithm becomes a black box. So there's this whole notion of what we call explainable AI. With traditional programming, you can actually pinpoint exactly why a program is doing what it's doing. But with modern AI, that's a little harder to do because these neural networks are very deep. They have sometimes 1,000 layers. So you don't know at what layer this data is being transformed into a decision, which could have. So explainable AI, the ability to interpret what this AI is doing and be able to explain why it's doing what it's doing, sometimes is hard. And, so that's one of the challenges that we have today.
I think that's an excellent sort of way to sort of transition into the other question I had. And we'll leave that sort of cultural bias or the human bias out there for our listeners to consider. One of the other fears is that AI is going to replace jobs. Can you make the argument that actually AI will actually increase or help job growth?
Absolutely, yeah. This is a great question. In fact, a few weeks back, I actually gave a small talk on this at a soft skills, meetup that we had. So one of the misnomers, if you go back to the earlier 20th century, in the beginning of 1900s, right? The largest percentage of jobs was farming, agriculture, big chunk. And today it's a very small percentage, right? So, when the automobiles came out, this notion we've had this notion ever since the last 300 years, since the Industrial Revolution, because machines at that time also threatened to take over jobs, right? But the exact same argument is being made today. We tend to forget that these machines and these industries create brand new jobs that didn't exist before automation, for example. So before computers, when computers came along, people were afraid that computers are going to take over a lot of jobs. But computers themselves have created so many new jobs, right? Since the 50s, you've got the development of the internet has created these brand new categories of things which never even existed, which we couldn't even imagine 50 years ago. Web development, internet, digital marketing, all of these jobs didn't exist before the internet, and they're all brand new jobs, right? iPhone developer, or all of these jobs didn't exist 10 years back or 15 years back. So these brand new jobs, if you really go back and look at how new jobs are created with new technologies, that's what the promise of AI is, and machine learning. So machine learning and AI hopefully will free us up from repetitive tasks, but the tasks that require the kind of things that we are good at, creativity and cognitive ability to think beyond what we currently do, soft skills, all of those things will become much more important. So we can't even imagine the kind of jobs that are going to be created, I think, in the next 20 to 30 years. And the big umbrella would be all of these new jobs are going to create new opportunities.
And that's an enlightening sort of way to ask then the next and sort of final question is what I'm hearing, and that's something that's positive, is that it'll open up within the world of automation, which came out of the industrial sort of revolution, is the ability for AI to free up mankind to actually think more and be creative and to be innovative, even if they're within a job skill set that is somewhat still structured. It still sounds like there'll be room for creativity because AI will allow them to have some more time to apply to innovation.
Exactly. Yeah, precisely. If you draw a 2x2 matrix where you get jobs which can be automated versus jobs that cannot be automated, and then you put another axis on creativity versus logic, there'll be one quadrant which will be jobs that are difficult to automate, which require creativity, and there's a lot of such jobs. And there are going to be things like taking care of, like for example, a good example would be doctors. Now, people are afraid that doctors are going to be replaced with automated machine diagnostic, like medical diagnostics too. For example, the stuff that we are developing, for detecting diabetic retinopathy is going to make a difference because there are areas in the world where they don't have enough ophthalmologists. But once you detect somebody has diabetic retinopathy, you still need somebody to treat them, somebody to counsel them, somebody to guide them. All of those jobs today can or could probably never be done in the future with a computer. You would need a human being, right?
So it becomes an add value process.
It becomes an added value, exactly. So the way one of the chief of radiology, the American College of Radiology, at one of the talks that I attended, she said that in the future, radiologists will not be replaced by AI, but radiologists that use AI will replace radiologists who do not use AI.
Well, now, and that is a fantastic way to transition into that last question I was referring to, which is the ability to train in the educational space and not, I don't like to use the word retool in this conversation because it doesn't sound like a retooling, but an enlightenment.
Yeah.
And how we can go about from a transnational or cross-disciplinary approach, because right now I think the perspective is that AI only goes to those that have computer science degrees.
Right.
But yet I think there is an interest, and I'm curious to hear your opinion on this, about how AI really can go across all mediums of a university with respect to whether you are a music major or a biology major, an accounting major, that AI can play a role in some part of the educational process without them becoming computer science experts or code writers themselves.
Yeah, absolutely. Yeah. In fact, I think it's a very important question because the future is going to be built on this new technology called AI. And therefore, it's very important that everybody becomes literate in it. And it's just like software in the 90s. Now today, when personal computers first came out, not everybody had access to it, but now almost everybody uses the computers for productivity. And, we literally cannot live without all the things that computers do for us. And we are all literate in some sense, right, in how we can use computers. And then the same thing is going to happen, I think, with AI. It's important for everybody to understand how this technology works and to be able to use it effectively, in their tasks to become more productive and to do useful stuff. And it's not something, unlike conventional software engineering and programming, which requires you to do programming. Actually speaking, AI and machine learning is easier to learn because it doesn't require traditional programming. A lot of these algorithms are standard algorithms, and a lot of the work of AI is collecting data, cleaning data, determining what kind of problems you want to solve, figuring out what are the right ways to measure the effectiveness of the solution. All of those things are not related to coding. they're more related to the kind of thing you conventionally think about in like management or in engineering or so, anybody who's got expertise in a particular domain can benefit by learning how they could use AI to solve problems in their domain.
And that is a wonderful, promising opportunity, I believe, because what you're really conveying is a message of simplicity for those that may be assuaged away from the concern that they're, if they were to learn AI as part of their major, right? That they would somehow feel that now they're not going to be focused in on economics, but rather on having to understand how the algorithms of AI will benefit economics. But what you're really saying is, no, it's more about how you are being trained in your economic degree or in your music degree to be able to be aware of the data that you may want to collect, and then the tools through these algorithms that can be then applied in order to then bring your performance, if you're in music, or bring your thesis or your predictions in economic policy to another level.
Yes, absolutely. Yeah, I mean, every domain can be benefit from AI because it's a kind of technology that sits on top of all the other stuff. So like software can be used in any field. The exact same AI can be used in any field to make it better. And I don't think there's any area of human endeavor which will not benefit from AI. There's a great, there are two great quotes about this, actually, which I think would be very relevant here. One is from Andrew Ng, who is one of the people who founded the Google Brain AI initiative within Google. And he says that AI is the new electricity. So just like electricity transformed every industry, it's going to be AI that's going to be transformed every industry. The second quote is from a gentleman called Kevin Kelly, who's founded Wired magazine. And he says the business model of the next 10,000 startups is very simple. Take X and add AI to it. And, whatever X could be, whatever endeavor, you add AI, it'll become better. So X plus AI would be the new, would be another startup. So you could take literally anything and add a layer of AI to it to make it better. So it's very important for all the people who are today learning whatever it is, it could be economics or marketing or, any of the other disciplines that, conventionally people are going to school for, would benefit greatly by understanding how this technology works and how they can use it to, make it better, make what they're doing better.
Well, I think this is a wonderful way to wrap up our program today on these inspiring quotes, and your summary as to how AI can be implemented in a way that is not fearful, but yet can be useful. And Arun, I want to thank you for the opportunity to share and explore this important subject matter and how it can touch all of our lives in a more positive way. As they say, sometimes the unknown is fearful, and therefore the fear itself then makes the unknown stay unknown. So you've hopefully opened up a little bit of the AI world in a way that our listeners will be less fearful of what they don't know, and then more importantly, how they can apply it in their daily lives and through their educational process and tools, trainings, and programs. I want to thank you for your time today. And again, this is Professor David Weiss, finishing another podcast programming from Connecting Bridges and Borders under the Institute for Dispute Resolution at New Jersey City University. Until our next one, I bid adieu. And thank you, Arun. Have a good day.
Thank you, David. Thank you. It was a real pleasure. Thank you so much for the opportunity.